In this video, we're going to be practicing using law of sines to find unknown side lengths. If you want to follow along, the links to the companion worksheet are in the description below. As with all the other videos in this playlist, we're going to be using degrees, so you want to be sure that your calculator is in degree mode. So let's get started. So here we have this triangle. It's definitely not a right triangle, and what we want to do is to solve it. That means to find the other side lengths. So, since we know that these two angles plus this angle add up to 180 degrees, that means that we can quickly find the measure of angle A. We take 180 degrees, subtract 30, and subtract 125. And when we do that, we get an angle measurement of 25 degrees for angle A. Now, to find lengths of side A and side C, what we have to do is we have to use law of sines. And we can use law of sines because that applies to any triangle. But additionally, we have an angle and a corresponding side. So therefore, law of sines applies. So the way we would write this is sine of angle 30 divided by that corresponding side, which is 10. And that's going to be equal to sine of angle A, which we found to be 25 degrees, over side A. And then that's going to be equal to sine of 125 degrees over side C. And so to solve for sine A, what we can do is I can just cover up this, and we can think of this as a proportion. So that means to find the value of A, we're going to cross multiply and divide. So A equals 10 sine of 25 degrees over sine of 30 degrees. And this is in exact form. Now, if your teacher prefers a decimal approximation, you can go ahead and do that. And we'll find that. So that's going to be 10 times sine of 25 degrees divided by sine of 30 degrees. And so we get a value of 8.453. Now, to find the value of C, we can do it the same way. We can just cover up this middle proportion. And so to find the value of C, we would cross multiply 10 times sine of 125 divided by sine of 30 degrees. And if we want a decimal approximation, we can find that as well. So on our calculator, we type in 10 sine of 125 divided by sine 30, and we get approximately 16.383. And 3 decimal places is about all you really need. All right. Now for the next one, we're going to do very much the same. We have this triangle that we want to solve. So here we have these two angles, 5 and 10. So that means angle C is going to be 180 degrees minus 5 degrees minus 10 degrees. And so that means that C is going to equal 165 degrees. Now, if we didn't know that, then at face value it would seem that law of sines would not apply here, because we have this angle, 5, and opposite that, B, we don't know. We have this angle, 10, and opposite that we have side A, which we don't know. And then we have this side, and opposite that we have angle C, which isn't given to us. But because we know these two sides, we know what angle C has to be. And so since we now know that, now we can apply law of sines. So we take sine of that angle that we just found, 165 degrees, divided by 5. And that's equal to sine of 10 degrees over A. And that's equal to sine of 5 degrees over B. So covering this up, we'll solve this proportion for A. So A is going to equal 5 times sine of 10 degrees divided by sine of 165 degrees. And we'll find that approximate value, 5 sine of 10 divided by sine of 165. So if your teacher likes an approximate value, then that would be 3.355. For B, we're going to cover up this middle proportion, And so we're going to cross multiply and divide this proportion. So that's going to be 5 sine of 5 degrees over sine of 165. And so on our calculator, we'll find that approximate value. And so roughly 1.684 is the value for side B. And so now we've solved this triangle because we found the angle and the two sides that we weren't given. So here, we say that we look up at a monument at an angle of 20 degrees. We step back 250 feet, and now our angle of elevation is 15 degrees. So the question is, how tall is the monument? So over here, we have some kind of monument. So some kind of tower, I suppose. And so we're down here looking up at it, and we're looking up at an angle of 20 degrees. But then we step back. We step back 250 feet. And then we look again. Now since we've moved back, we don't have to rotate our head so much to look up and see it. Now what we have here is we want to know the height of this. However, this picture right here, this triangle, is what we're interested in right now, because we need to know something about this triangle. And so since this is in law of sines, we're going to be using law of sines to help us. So let's see. We know this angle is 15. This angle over here, this has to be 160 degrees, because this is going to be supplementary. Because if I were to continue to draw this, this would continue along the horizontal. Now, since we know 15 and we know 160, that means this angle here has to be 5 degrees, because all three angles add up to 180. Now the question becomes, what are we looking for? Well, the only two things we don't know are these two sides. And in reality, we could find either one. And I'll choose to find this one, this length right here. So to set up law of sines, we know sine of 5 degrees over 250. Now let's see, x is opposite this angle, 160 degrees. So I'll write sine of 160 degrees over x. Now I'm not going to write the third one because that would have us find this third side. Don't need it. You'll see why. So when we cross multiply, x is going to equal 250 sine of 160 degrees all over sine of 5 degrees. Now, we're going to need an approximate because we're going to use that answer to then find the height. So 250 sine of 160 divided by sine of 5. And so that is approximately 981.060. Now the height of this monument is always drawn perpendicular to the ground. So what we end up having is we have a right triangle here. Let me draw that. So down here we have our right triangle where we know that the angle is 15 degrees because this is where we were out here looking up at it. We want to know the height, and now we know that this length is what we just found, 981.06. So this just requires a trig ratio. This is the opposite side of the angle, and this is the hypotenuse. So we'll use sine. So sine of 15 degrees equals h over 981.06. So we'll multiply that over 981.06 equals times sine of 15 degrees, and that's going to equal h. And we'll find that approximate. And so h is roughly 253.917 feet tall. So this problem required both trig ratios like we used with right triangles, but also required law of sines. If you like this video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.